One of the most intriguing discoveries in modern science is the fact that there is nothing in this world that even approaches what might be called truly solid. We speak of solids, liquids, and gases, but these terms describe superficial rather than basic properties of matter. All matter, regardless of its state, is composed of invisible particles called atoms, which in turn are composed of other particles. The air we breathe, though invisible to us, is just as real as wood or metal, because it's made of the same fundamental particles. It is the arrangement of these particles and the forces that bind them together that give to a substance its special properties. If we bring a piece of steel close to a magnet, we say that the steel becomes magnetized. But what is it that actually happens? If we place the steel inside a coil of wire connected to a high-gain amplifier, and then bring the magnet close to the bar of steel, we can hear something that suggests movement inside the steel. Listen. We think of a piece of steel as being solid, and according to our definition, it is a solid. But the popular concept of what makes a solid is certainly a false one. This piece of steel, and any so-called solid substance on this earth, is almost entirely empty space. If we could eliminate the empty space in this piece of steel, all that would remain would be a tiny bit of matter, so small as to be invisible even with a high-power microscope. This concept of almost unlimited empty space within matter is comparatively new, but it is the very cornerstone of our knowledge in this atomic age. Atoms are not solid. Instead, they are tiny solar systems composed of infinitely small particles revolving at tremendous speeds and bound together by enormous forces. And like our solar system, atoms are almost entirely empty space. For the moment, let's forget the forces within the atom. Thinking only of the particles and the empty space around them, science knows no reason why I couldn't take this so-called solid steel bottle and just throw it right on through that wall. Except this, we've tried it and it hasn't worked. If I were to attempt to run through that wall right now, all I'd get for my trouble would be a good-sized lump on the head. But that which would prevent my body passing through the wall would not be a collision of particles, but rather a collision of forces, the same forces that make an atom bomb. And if it were not for these forces, my body could go freely back and forth through that wall, just as though it were not there. It is within the realm of scientific possibility that there could be two worlds coexistent, occupying the same part of space at the same moment of time, each world just as real as the other, with its mountains, valleys, rivers, trees, and people. And that one world could pass freely through the other world, neither world being conscious of the existence of the other world, if you grant just one thing. Atomic forces within the material substance of these two worlds that are not mutually interactive. What do we mean by this? Let's see. Here are two pieces of steel. Their appearance is quite similar, but a magnet will reveal a basic internal difference between the two pieces. This one, of course, is picked up, but this one is unaffected. This piece of steel is non-magnetic, stainless steel. Of course, we all know that other metals, such as brass or aluminum, are not affected by the magnet. But a ring made of aluminum is something else. It can be suspended in air by the electromagnetic force of what is actually a transformer. The ring being in effect a one-turn shorted secondary. A smaller ring will react even more violently. Here is another ring. This one made of a material we say is non-conductive. And it is completely ineffective. Here is another example. Several thousand watts of power were involved in that spark. If we replace the spark gap with a copper coil, the same power now flows through the coil. It's invisible, has no effect on many substances, but it can generate a lot of heat. Wood, paper, things that we think of as being quite inflammable are not affected at all. However, a piece of steel wool bursts into flame instantly. Did you ever fry an egg on a cold stove? It's no trick at all if you have the right equipment. This is a cold hot plate, and because it's cold, you can make it out of wood, if you like. Just be sure that there's a coil of wire inside and that you connect that coil to a high voltage alternating current source. The rest is easy. As long as we're being different, we'll use motor oil instead of Crisco. The egg fries very quickly, but the stove remains perfectly cold. In fact, if you wish, just to keep it handy, you can fry your egg on the morning newspaper. With a gadget like this, you can get up in the morning, sit on the stove, read the morning newspaper, and fry the eggs in your lap. Another example of the fact that physical forces can be quite selective in their effect. All of the examples which we have cited thus far have been in the physical realm, and of course have been limited by that fact. We can, however, cite examples that transcend the purely physical and clearly demonstrate the reality of these two worlds.